A study is conducted to see whether there is a relationship between smoking and blood pressure. Random sample of 143 subjects is selected, and they are classified as follows. So we have the smoking status, smoker or non-smoker, as rows, and the blood pressure, low, moderate, or high, as columns. And so here are your data. And the first thing you might want to do is start to calculate totals, the row totals and the column totals. So if we go 15 plus 36 plus 27, we'll find a row total for row 1 of 78. Row 2, the non-smokers, if we go 9 plus 44 plus 12, we find a total of 65, which means that 78 smokers were classified according to their blood pressures and 65 non-smokers were classified according to their blood pressure. If we add 78 plus 65, we'll get a grand total of 143, which corresponds to the size of the sample. If we do the column totals, 15 and 9 is 24, which means that of the people asked, 24 had low blood pressure. 6 plus 44 is 80, which means that 80 had moderate pressure. 27 plus 12, which is 39 of those 143 subjects, were classified as high pressure. Again, the sum of 24 plus 80 plus 39 give us 143. So this is always some work to do. And then the question, at 5%, can we say that blood pressure is related to smoking? So the wording of this question, like first asking whether or not there is a relationship. So when it talks about relationship, dependence, independence, something related to something else or not related to something else, that is a giveaway that it is a test for independence. So in here our null hypothesis, so the conservative hypothesis is to assume independence. Because why should we assume that there is a relationship? That has to be proved. So in here the null hypothesis is that there is no relationship, like in the test for correlation we would say rho equals 0. In here we don't have a parameter, so we say there is no relationship between blood pressures and smoking. Similarly, the alternative hypothesis is going to be not the null hypothesis, so there is a relationship, or in other words, blood pressure is related to smoking. So the other thing that we have to do, we have to calculate the expected values. I will write them in brackets in the table, and I will round them off to 2 decimals, but we have a little bit of guidelines. So I will add them on the tables in brackets. Now, it's good that you show how to calculate them, but basically give the formula. So E11, for instance, cell 1, row 1, column 1, is going to be row 1 total times column 1 total. So it's basically your row total times your column total divided by n. And so for our example, it will be 78, which is row 1 total, times 24, which is column 1 total, divided by 143. And similarly, E12 will be 78 times 80 divided 143, and so on and so forth. So show me one full calculation, and this is going to be equal to 13.09. The 09 repeats. If we continue calculating the expected values this way, we'll find 43.63 and 21.27 for the first row. And for the second row, we'll find 10.90, 36.36, and 17.72. So if we take a first look of the data, the expected value seems to be quite in line with the observed values when there is low pressure, but when there is moderate or high pressure, they seem to be more far away. So the discrepancy seems to grow with the growth of the blood pressure. So now, if we calculate the test statistic is given by the sum of difference squared between observed and expected, each divided by the corresponding expected value. And so I started writing down the first one, 15 minus 13.09, squared divided 13.09, and keep going until you reach the last one, which will be 12 minus 17.72, and then squared and then divided by 17.72. And when you do it on your calculator, you'll get a total of 6.94. Now, our step 3 and 4 is the critical value. So in here, the alpha value is 5% or 0.05. And the degrees of freedom are number of rows subtract 1 multiplied by numbers of columns subtract 1. So number of rows subtract 1. So we have basically for degrees of freedom, we have 2 rows. So we need to go 2 minus 1, which is going to be 1. Multiplied by number of columns, we have got 3 columns, subtract 1. So 3 minus 1 is 2, and 1 times 2 is 2. So the degrees of freedom will be 2. So we need to look up at on the chi-square tables of 5% and 2 degrees of freedom. Critical value is 5.99. So this test is always right-tailed. So we are comparing the calculation value, which was 6.94. We are comparing with 5.99. So if we put it on a little graph, so this is a rejection region and 5.99 is the critical value. And we have got 6.94. It falls inside the rejection region. So we can say that because chi-squared is equal to 6.94, and we are able to reject the null hypothesis. And therefore, rejecting the null hypothesis basically means accepting the alternative. And so blood pressure is related to smoking at the 5% level. Now, the accept null hypothesis can be tricky to word. If we had accepted the null hypothesis, not this case, we would have had to say that we didn't have enough evidence to find that one depended on the other. So, but if we reject the null hypothesis, we can find a relationship. So we can say that one depends on the other. Let's see a different example. In order to test the effectiveness of a new drug, one group of individuals is given the new drug and another group a placebo. The results are shown below. So we have a 2x2 table. We can see because we have 2 rows and 2 columns, and we have effective and non-effective and drug and placebo, and the numbers are given in here. So, and we want to know at alpha equal 10% if the researcher can conclude that the drug is effective. So the first thing I'll do, I will start calculating my totals, which will also provide me the total number of people that were screened. And so 32 and 12 is 44, while 9 and 18 is 27. So 44 people, there was an effect, and 27 it was not effective. And the grand total is also called N and is gonna be equal to 71. People given the drug were 32 plus 9 or 41, and people given the placebo were 12 plus 18 or 30. Again, the total is 71. So as usual, the null hypothesis is a no relationship. So independency between effectiveness and being given the drug. So that means that the drug is not effective, because if the effectiveness does not depend on the medication, that means that the drug is not effective. So it's a good idea in these cases, which are a little bit more, you need to think a little bit, is a good idea to basically translate in terms of the question what it means. So make sure you don't memorize it. It has to make sense to you. Now, because this is a 2x2, we need to use Yale correction factor. So the chi-squared value will be calculated a bit differently. But before I go into the chi-squared value, let's calculate the expected values, which as usual I'll put in brackets. And the expected values are still calculated as row totals times column total divided by n. I'll show me the calculation of the first, and then we can go from there. So for the first one, we'll have, for E11, we'll have the row total, which is 41, times the column total, which is 44, divided by 71. And then we'll round to 2 decimals. So the first one is 25.41, and similarly the second one is 15.59, and then 18.59 and 11.41. And so the correction in the formula is that before squaring, we need to take the absolute value of the difference between observed and expected, and then subtract 1/2 or 0.5 and then squared and then divide by the corresponding e. So when calculating the chi-squared, the first one will basically be absolute value of 32 minus 25.41 and then subtract 0.5 and then square and then divide by 25.41. And if I put it on my calculator, the total value will be 9.08. So this is quite a large value for my chi-square distribution, and so very likely we will end up rejecting the null hypothesis. The critical value calculated at 10%, the degrees of freedom in a 2 by 2 is going to be 1, because we have 2 minus 1 times 2 minus 1. 2 rows, the number of rows minus 1 times number of columns minus 1. So we need to go at 10% and 1 degree of freedom, and that will give us a value of 2.706. And therefore the critical value falls in the rejection region. Remember, this test is always right-tailed. High value of the test statistics when compared to the table value favor the rejection of the null hypothesis. So the null hypothesis is rejected in favor of the alternative. And so we can say that at 10% is a relationship between being given the drug and finding an effect, and therefore the drug will be effective. Thanks for listening and practice.